Hi, dear students. So let us see this question that came in KVPY 2016 essay 2021 physics paper. Now, in this question, basically what happens is there's a guy who's walking at a constant speed v, okay, and he's holding some water glass or something, water container, in which some water is filled. So basically, it is seen that water starts spilling over because of his walking. Now, why does this happen? Okay, so first let me complete the question. So it is given that if the time period of oscillating water, okay, is proportional to root of h, where h is the height of the water filled in the container, then v is proportional to like we have to find the proportionality of v with the radius of the container. That means like what power of r will be proportional to v, velocity of the person walking. So basically it's a common observation. Suppose you are holding a uh, like suppose you're holding this type of glass, okay, and suppose this height of water is filled in the container. Okay, so because of your walking, like suppose this is the hand of the person, okay, and because of and this is the body and this is the like hold on, I've drawn very bad picture. So suppose this is the feet of the person. So whenever he will walk on the ground, there will be periodic impulses that will be given by the ground. Okay, so if you put your foot on the ground, there will be an impulse from the ground. So like if you suppose you are taking f number of steps per second, okay, suppose you are taking so f number of steps per second. So what will happen, like whenever you keep your foot on the ground, there will be an impulse from the ground, okay. So that impulse will be kind of transformed to the container as well, because like your full body feels that impulse, so your hand will also feel that impulse. So we can say this water is also getting a periodic impulse of f number of times per second, right? So water will start oscillating like this, dig, and it will spill like this, and then it will spill like this. So water will be oscillating with the time period of capital T. Okay. Now, at the resonating condition, we can say that the frequency with which you take the steps will be equals to frequency of oscillating water, right? It is very very obvious when the resonance will occur. So we can say that frequency with which you are giving the impulse to the water, that will be the frequency of oscillation. Okay, it's a common observation. When somebody is moving on a swing, or when a small kid is sitting on a swing, then the frequency with which an external person pushes the swing is equals to the frequency with which swing oscillates. So that is the same case over here. We can say that frequency with which the impulse will be given to the water container is the frequency of oscillating water, and also is the frequency of number of steps that you take per second. So let's say that frequency is f. Okay, so that means f represents the number of steps that you take per second, and let's say small l is the length of the step. So that means if a person is taking the length of the step, that means the distance between 2 feet, distance between two of his feet is equals to the length of the step. Okay, step size. Okay, so number of steps is f per second, and l is the length of the step. That means suppose his 1 feet is here and other feet is here, so this is what we are calling as l. So we can say this is the distance he will travel in 1 second, right? If f is the frequency of the step and l is the step size, so we can say this is the distance he will travel in 1 second, which is nothing but velocity. What is velocity? That is simple. We can say that distance traveled per second. Okay, so f into l becomes v. You can see that dimension is also matching. Length has a dimension. L will be having a dimension of length, and f will have a dimension of per second. That is time inverse. So this is the dimension of LT inverse, which is the dimension of velocity. Now, as I said, this f will also be the frequency with which water oscillates. So let us say this f, this f is like this f is the frequency with which water oscillates, and it is given in the question that time period of the water oscillating is inversely proportional to root h. Okay, so we can say that frequency of water oscillating will be directly proportional to root h. So we can say that f is directly proportional to root h. Okay, so we can say that f is directly proportional to root h. Now, What else f can depend upon? So in the question, we can see that there are some variables which are given. So f can depend upon, let us say, r to the power a times. We do not know still what will be the value of a. Then what else f can depend upon? F can depend upon density of water. We still don't know if it will depend upon density or not. But let us assume that if it has to depend, then b will get some value. If it does not depend upon density, then b will be zero anyway. And also f can depend upon gravity. Okay, gravity of the earth. Okay, so let's say it depends upon g to the power c. Okay, so these are the some variables which I have assumed. Okay, whatever, if there is no dependency on certain variable, then that particular power will come out to be zero. Okay, so now we can think of this f as some constant lambda times r to the power a. Also, sorry, yeah, so r to the power a, rho to the power b, and g to the power c, and h to the power half, right? So this is the frequency with which we can say, now frequency has a frequency has a dimension of time inverse. We know that. So T inverse will be is equals to lambda as a dimensionless constant. R has a dimension of A. So we can say R has a dimension of length, sorry. So this will be L to the power A. Density is mass per unit volume. So M to the power B, and per unit volume will be L to the power minus 3 times B. Gravity is meter per second square. So meter is L to the power C, and per second square is T to the power minus 2C. Okay. And H has a dimension of L. So we can say that, uh, hold on. So we can say that this H has a dimension of L to the power half, right? So now we can equate the dimensions on both the sides. So if you see, so here we do not have any term of mass. So that means B is directly equals to zero. That means frequency does not depend upon density. Okay. Also, we see that there is no dimension of uh, length. So we can say that A minus 3B. B is anyway zero, so this term I'm not writing. So A plus C plus half, that will be equals to 0. Okay. Also, if you equate the dimension of time, so minus 2c and minus 1 will be same. So we can say that minus 2c will be is equals to minus 1, which gives us the value of c as half. So from here c is half, so a becomes minus 1. So now we are ready to write the formula of frequency. So frequency becomes some lambda times r to the power a, that means r to the power minus 1. Okay, and density is not required. Gravity to the power c. C is given as half. That means root of gravity. Okay, and what else? H to the power half. Okay, that means root of h. Okay, so this is the dependency of frequency, right? So we were asked that what is V proportional to. Now F is also equals to V by L. So from here we can say V by L is nothing but lambda r to the power minus 1 root of gravity into root of h. So we can say that V is proportional to r to the power minus 1. That means V is proportional to 1 by r, right? So option D will be the correct answer for this question. I hope you would have understood. Thank you.